Hello, good evening. In the pretext of Saraswati Pujo, the goddess of knowledge, I thought to do a little bit of reflection on the nature of knowledge and learning. See, the way I see nature is simple, right? But the complexity is inside our mind. To illustrate this point, I will take an example from a very classic book. This one, I think it can generate some nostalgia in some of your minds, right? So this is the Irodov Problems in General Physics. I will pick problem number 1.81 and try to solve that problem. And in the process, we will discuss how knowledge simplifies stuff and how one of the important goals of learning is to simplify our thinking process and simplify our life. Again, the way I see complexity is inside our mind only. Okay, let's see. So the problem 1.81 is saying this. So there is a surface, frictionless surface. On this frictionless surface, there is a prism of mass m1 and this angle is alpha. So this prism is lying on this surface. Now you put another block of mass m2 here. And this surface is also frictionless. Now what will happen? So essentially this mass m2 will start sliding along this direction with some acceleration, and as m2 is sliding, the m1 will move in this direction with some acceleration. So let us assume that acceleration of m1 in this direction is a. So the problem is to find the value of a. Now, to solve this problem, we will apply obviously Newton's law. And again, like if you get the crux of Newton's law, it's very simple. Newton's law is essentially saying if on an object, say of mass m, couple of forces are acting, the net force on this object, if you add all the forces together, the net force F is equal to mass time acceleration of that object, right? So we will use definitely that principle in this case. So let us see what are the forces acting on this m1. So obviously, so this guy is lying on this surface, so there will be a normal reaction n1 by the surface to this object. See, the object is also giving equal and opposite direction normal reaction on this surface, but we are not considering the forces on this surface. We are considering the forces on this object, the m1 object. Now that is a normal reaction. What other forces acting on this object? Definitely this object has a mass, so there is a weight, the pull of the gravity in this direction, which is m1g. What else? So this object, the m2, there is also a surface contact, right, between m2 and m1. So here m2 is also giving a normal reaction perpendicular to this subject, surface. So this normal reaction is n2. So these are essentially the three forces that are acting on this object. Now let us do a quick redraw all these forces from the same point, and let's see what is happening. So this mg's object is acting. So now before starting the analysis, let us set the frame of reference from where we are computing the motion of this object. So obviously the frame of reference is this thing, right? And this is the y-axis, this is the x-axis. And we can say this frame of reference is inertial, it is not moving. Let's assume that. So this frame is not moving, and from this frame, say you are sitting here somewhere on this frame, and you are observing the motion of this object M1. Now, all the forces that are acting from your perspective, from this point of frame of reference, you are seeing the forces that are acting on M1 are M1G towards this direction, the negative y direction, and on the positive y direction there is a force N1, and obviously there is a force N2 in this direction. Now from the physics of the problem you can clearly say there is no motion along the y direction. So all the forces along the y direction should cancel out. Only net force will be in the positive x direction, which will give the acceleration of this object. Now in positive x direction, what is the force? So now let us do a little bit of component analysis. So now if you do a little bit of trigonometry, you will see if this angle is alpha, this angle has to be alpha. Why alpha? Because this N2 is basically this, which is perpendicular to this surface, right? And this one is basically perpendicular to this surface. So the angle between these two should be same as angle between their perpendiculars. So if this is alpha, this has to be alpha, right? Now, if this is N2 and this is alpha, what is the value of this one? N2 sine alpha. Now, so this is the net force in positive x direction on the mass M1. So we get our equation. Just apply the Newton's equation. So M1A is equal to this net force, unbalanced force, into sine alpha. So this is our equation number 1. Now our goal is to figure out A, right? Now we can see here there is an unknown N2. So somehow we need to find out this value N2 and substitute in this equation and then get the value of A, right? That is our goal. Now this is fine. So this is what we can get from the equation of motion of this object. Now we need to find out some other equation of motion for the object M2. Now this M2 is a little bit complicated, right? See the motion of M2. So first of all, the M2 is sliding along this surface. At the same time, the whole thing is moving in that direction. So if you see the curve of the motion of M2, it's quite complicated, right? It has some motion in this direction, some motion in this direction. But if you try to if you try to reason from this frame of reference, from where we computed the motion of M1, if you try to do the same thing for M2, it will be quite complicated, right? You may try, you may probably come up with a set of equations and you can solve and get the result, but that will be complicated. Now let's see in this situation how a simple idea can simplify solving this problem. So the idea is, let's think a little bit deeply about frame of reference. So let us assume we have a frame of reference. So this is my x-axis, this is my y-axis. Let's assume this frame of reference and you are sitting on top of this frame of reference. On this reference frame. You are sitting here. Now from this reference frame, say there is an object. And this object mass is m, and there is no force acting on this object, and this object is at rest. Let's assume. Now you can reason, okay, on this object there is no net unbalanced force and there is no acceleration, which is fine. Now suddenly if this frame of reference, if your reference frame start moving in this direction with an acceleration A, what you will see? You are still sitting on this reference frame and you are not aware that the frame of reference is moving with some acceleration. So what you will see here? You will see that on this object M, there is no force, no net force, but this object is moving in this direction with an acceleration A, right? If you move in this direction, you will see the objects moving in the other direction with same acceleration, right? Because you are not aware of your own motion. So now, how you will reason it? So, but I mean, you know, but you don't know at the same time that the frame of reference is moving. But in this case, to reason that this object is moving in this direction, you can assume that there is a force acting on this object on this direction, which is capable of giving it an acceleration of a. So basically on this object, there is a force acting which is equivalent to ma on this direction, right? Now once you assume that, but obviously this force doesn't exist in reality. This is an imagination. So we call this thing a fictitious force. So now from an accelerated reference frame, which is not inertial, you can still apply the Newton's law of motion, but you need to assume this fictitious force. Now let's say this simple idea, if we apply in this situation, how it simplifies this problem. So we can see like if I can take my reference frame for while analyzing the motion of the object M2, if I take M1 as my reference frame, then the motion of this object M2 with respect to M1 is simple, right? It is just moving in this direction. No other motion. It is not moving in this direction compared to this guy, but it is moving in this direction only, right? So, but only thing is that once you set your reference frame this object, so that means you can think like as if this is your x direction, y axis, and this is your x axis. While analyzing the motion of this M2, if you take your reference frame like this, see how it simplifies the problem. So now the first thing, because your reference frame itself is now accelerating with certain acceleration on this direction, to analyze the motion of this object from this reference frame, you have to assume a fictitious force on this direction, which is giving this M2 the acceleration same as acceleration A, but in the opposite direction. So you have to assume a force of M2A acting on this object in this direction, right? Now see, what are the forces acting on M2? So on M2, there are three forces acting. So one force is obviously this fictitious force. Now keep in mind, we are analyzing from the perspective of this reference frame, this object. And from this reference frame's perspective, there is no motion in y direction. Motion is only in the x direction from this reference frame, right? From the reference frame attached to this mass M1. And my y direction is this direction and x direction is this direction. Now there is no net motion in y direction. So all the forces along the y-axis should sum up to 0. Or other way we can say the sum of the forces in the positive y direction is equal to the sum of the forces in negative y direction. So okay, now let us figure out what are the different forces acting on the mass M2. So on M2, three forces are acting. So one is obviously the normal reaction from this surface to that M2 object. So this normal reaction is acting on this direction. So let's just put it like this. So this is M2 on that direction. And then we have obviously this fictitious force which is producing an acceleration equal to A. So A is the acceleration of this object in this direction. And because we are now computing from the reference frame of this object, we have to assume this fictitious force in this direction. And also there is a force of due to gravity. So that is M2G that is acting in this direction. Now from the reference object of this frame, we can say, like from M1, we can say this M2 object doesn't have any motion in y direction. So the net forces in positive y direction should be equal to net forces in negative y direction. Now if you do a little bit of trigonometry, you will see that this angle is alpha and also this angle is alpha, right? Now, if this angle is alpha, what is the component of M2A in this direction? So in this direction, net forces is definitely this M2 plus M2A, the sine theta. Sorry, sine alpha. This should be equal to the forces in the negative y direction. In negative y direction, the force is basically the component of this M2G. So this M2G cos alpha. So you get this equation, right? Now from this equation, what you can say? You can say M2 is equal to your M2G cos alpha minus M2A sin alpha, right? So you got your equation number 2. And that's all you need. Now if you substitute this equation number 2 into equation number 1, it will be an equation in A only. A is the only unknown. And that's what you have to find. So let's just substitute this M2 into the equation number 1. So what we are getting? M1A equal to M2G cos alpha minus M2A sin alpha multiplied by sin alpha. Now do a little bit of manipulation. You see A, M1. This term will come to this side. You will see M2 sin square alpha is equal to M2G sin alpha cos alpha. Now if you do a little bit of manipulation, then your A will become G sin alpha cos alpha divided M1 by M2 plus sin square alpha. And let's make sure this answer is correct. So this is 1.81. 1.81 acceleration is G sin alpha cos alpha sin square alpha plus M1 by M2. That is exactly what you got here. Now you see how the clarity, like first of all, the ideas. See this inertial or non-inertial reference frame, how simple is that idea? So the important thing is that you have to understand, you have to grasp that simplicity, right? And then you have to have the clarity of the physics of the problem so that you can apply this simple idea into this situation, right? And once you are able to apply it correctly, you see how easy it is, right? Without this simple idea, if you just try to do, naively, the motion of this object, that M2 would be like so much complicated. And I don't know, like even I'll be able to solve in that way, right? So now, do you see the point? The knowledge and learning, the way I see, one of the important goal of knowledge and learning is to make things simple so that we can solve problem the most simplistic way possible.